Hello. The topic for today is polar to rectangular equations conversions. To explain this topic, I'm going to use some examples. That's very important to explain and to teach how you do the conversions from polar equation to rectangular equations. Before to start with examples, I need to remember these very important equations. Rx is equal R cosine theta, y R sine theta, x squared plus y squared is R squared. Using this, you find the square root, you get an R, and the tangent of theta is y over x. My first example is R equal 9. This is in the equation in the polar coordinate system. Then, using this expression, R is x squared plus y squared equal 9. And now, to eliminate the radical expression, you do the exponential to square, and you eliminate the square root with this square, you cancel the square root, and you have x squared plus y squared, and 9 squared is 81. This is the circle with the center 0, 0, and radius 81. Now, example number two. R equal 6 cosine of zeta. Remember, change the R. I need R. I need R here, because if I have R here, R cosine of theta is X. Now I need an R here. Then I multiply everything by R. And when I multiply by R squared. And R squared is x squared plus y squared is x squared plus y squared. And you get a 6, and x equals R cosine of theta is x. And now we move this to this side, and now doing the completing square. 6 divided by 2 is 3, to square is 9, and I add 9 to the both sides to do the complete square. And finally is this a circle with center 3, 0, and the radius 3. Another example. Example, zeta equal pi over 6. When you have this situation, I need to use this relation. The tangent of theta is y over x. Now you apply a tangent. Tangent of theta is equal to tangent of pi over 6, but a tangent of theta is y over x. Tangent of theta is y divided by x, and the tangent of pi over 6 is square root 3 divided by 3. And now this x is dividing this expression. You move to another side, multiply it, and this is a line. This is the equation of the line. Next example. A secant of theta. Secant of theta. You change the secant to 1 over cosine. So secant of the angle theta is 1 over cosine of theta. That's what I'm going to use here. And when you multiply by A, you have A over cosine. Now, cosine is divided. When you move to another side here, you multiply. And now R cosine is X equal A. That's the vertical line path for X equal A. Another example. Let me erase this one. Another example. This one. Because this expression is in the denominator, when you move to another side, you multiply R by this expression, equal 5. Or you can do cross multiplication. R, this and this, 1 times 5, cross multiplication. And now you do distributive property. 2R and distributive property. And I have r cosine of theta is x, and r sine of theta is y. And I have the line. This is the equation of the line. Example number 6. The same thing. You have one here. You can do cross multiplication, and you have r sine of theta. 1 times a is equal a. R sine of theta is y. Y equal a, horizontal line. Now we're going to do another example. Our example now is r squared r squared sine of 2 theta equal a. Before to do this exercise, I need to remember you one trigonometric identity. And this is the sine of 2 sides, the sine of 2 theta is equal to sine of theta cosine of theta. This is the trigonometric identity, very important. I'm going to use this in back example. I'm going to change sine of 2 theta, I'm going to change by 2 sine theta cosine of theta. I'm going to change this one. Now, you have r squared. Now, this is r times r. Okay, times r. Then I have 2r. Then I'm going to use 1r to combine with sine and another r to combine with cosine. Because I know that the r cosine of theta is x and the r sine of theta is y. Then I combine this one, one r to the sine, I am here, and another r to the cosine, I'm here. Now r sine is y, and r cosine is x. Now 2yx, and leave it, and you solve for y, and this is the expression in rectangular form, 4 over x. Another example number 8. I have this one. You can do cross multiplication or change sine squared theta is 2 sine is sine times sine. Sine squared theta is sine times sine. And now cosine divided by sine is cotangent. And I move this sign in the denominator to this sign multiply. Then r sine of theta is y. And a cotangent, tangent is y over x. But cotangent is the reciprocal, is x over y. Now, doing now cross multiplication, 1 times 5x is 5x, and 1 times y is y squared. And this is my answer. Now we're going to do the last example. Our example 9 is r sine theta cosine squared theta. Then, you see my example. I need 1r here, and I need 2r here, r and r. I need 1r here and a 2r. Because if I have 1r here and a 2r here, because cosine squared is cosine squared theta times cosine squared is 2 cosines. Cosine squared is 2 times 2 cosines. Cosine theta and cosine theta, multiplication. I need 3r. I need 1r here, 1r to this cosine, another r to this cosine. Then, what I'm going to do, I'm going to multiply by r to the third power. And when I multiply by r to the third power, r to the third power times r to the third times r is r to the fourth power. And now, when I multiply by r to the third power, I have the 3r, r, and r. That's r sine r is r to the third power. Now r to the fourth power, I can write it like r squared to square, using the power of power. Because you multiply this exponent, 2 times 2 is 4. Now, using my expressions, r squared is this one, r squared is x squared plus y squared. R sine theta is y. And r cosine is 1x. and an r cosine is another x, and an x times x is x squared. Now what I'm going to do, I'm going to find now the square root of this one, and the square root of this one. When I find the square root, I can cancel this, cancel square root, and this x is going to be outside, and my answer is x squared. You get this, but you could cancel a root. You go x squared is going to be upside because you cancel the 2 with this, but y is inside, and this is the final answer. Thank you very much to watch this video. I will see you in another video. Bye.